think that's my signal to start. Let me introduce myself very briefly. I'm Liz. Hi. I hope you've had a good morning. I want to tell you a little bit about something that's important to me in lieu of introducing myself properly. The most important thing at the moment for me is climate change. I don't do a talk without talking about climate change. I speak at a lot of conferences. This is me sitting in front of a bus in the middle of Banks in London. I have actually joined Extinction Rebellion. I wanted to tell you why. This is the graph that's from the IPCC reports that I saw that made me do that. That bottom graph shows what happens at various temperature levels. So the grey bar is 1.0, that's already happened. There's the 1.5 temperature, you can see everything goes red. At 2, they're trying to keep us to 1.5 to prevent some of the tipping points, some of the feedback cycles that they reckon will happen at 2, at which point it starts running away from us and it becomes increasingly hard for us to do anything about it. We are currently on track for 3.2 by 2050. It's not even on the IPCC's charts. If you want to know more about that, I wrote a blog post on it. It's got some of the sources. It's got some links to stuff that's already happening in the world. It's already really quite bad. It's called Off the Charts. Anything you can do right now to help fight climate crisis is really super important. Please contact your representatives. Email them, let them know that you're worried about this, that they can act, and they've got your backing to do so. Obviously, anything you can do as individuals, reusing, recycling. We took the train here from London. It took us 2 days. I'm trying not to fly anymore, so 2 days here and 2 days back. It's worth doing. Thank you for listening. Okay, Kotlin. That's what we're here for. So I wanted to talk a little bit about why I still program on the desktop. I am not a professional developer. I gave that up some years ago. I tend to do agile coaching, leadership stuff these days. But I still program for fun. Back when I used to be a professional developer, I was always desktop-based. And there are still some people who really, really love desktop apps, traders, anything where it's super complicated, and you don't want to have to be worrying about scaling and how it performs on different browsers. It just needs to just work. Desktop, you can fix the size of things. You can. It's got a lot more simplicity to it. The other reason I really, really love desktop is because when I'm developing in JavaFX, it is one language. One tool, it's just there. The learning curve for me is so, so small. I don't have to worry about how to deploy to an Android phone, how to get something working on the web. And I've been using this as a tool for teaching people as they come into software. So I've been using desktop as a way of helping people learn to code. And it's really, really easy for them, really satisfying to see something coming up on the screen. But it's still one language, so the learning curve's a lot smaller. For me, since I'm doing this in my spare time, I'm not doing this professionally, I've found I've come back to the place where I have the same kind of constraints as people who are new to the industry. So this is one of the reasons I really like desktop. I am going to be doing this super, super fast today. If you want to follow along, all the code that I'm going to be showing you is available on my GitHub. It's called Hellbound. It is a Tetris game where we drop things into a burning pit. Right? That's why it's called Hellbound. There's a little bit of history to this game. I am best known for my involvement in the BDD community, behavior-driven development. Back when we wrote JBehave 1, which was the first BDD tool, we needed something that actually exercised JBehave and showed how JBehave worked. And the first iteration of Hellbound was written in Java, I think it was Java 1.3, so it's before generics were even available. It was written in Swing. And we used it to drive JBehave and to drive the development of JBehave. So I'm super, super happy to be coming back to this with JavaFX and TornadoFX today. Let me show you the app. Here it is. This is the first iteration of it. So it's literally just an app. It's got this main view. We start it up here. Right. It's got this lovely main view here. If I have a look at the main view, it's just got an Xbox in it. So if I go back, Hellbound, and I just run this, and you'll have to excuse me, I'm not a professional dev, which means I'm running on Windows, not a Mac, but there it is. Okay, so it's a box. It's got a default size. There's nothing else interesting about it. Now, ordinarily, if I was programming using JavaFX, I would have to declare this thing at the top, and then in my init, I would have to do things like maybe I want a border pane inside something, so I'd have to declare a border pane equals border pane. Oh, this is boring. Oh, and then we'd have to kind of add the border pane. Okay, this is just tedious. I don't want to have to do this. This is JavaFX, right? TornadoFX does something a little bit magical. It takes away a ton of the boilerplate code, and it makes it super, super fast to get things up and running. So I can just do this. Now I've got an HBox, and we can import that from Tornado, and I can add a border pane if I want to. And I can do, so let's say I want to put a button on the left-hand side. I can do left, I can do button, and we can import those. Oh, not that. Import. Thank you, TornadoFX. Not that either. That's a style sheet. There we go. Okay. And now I can put something in here. So if we were doing JavaFX, we would have do on action equals, and then we have some event listener. I don't even remember what that looks like, so I'm just going to make an object that extends an event listener. Okay, this is already again, it's going to be tedious for you to watch this. We don't actually need to do that with Tornado because it's got action. It's got sensible stuff for just about everything. So you can literally just throw the action in here. It's got some support for dialogues as well, so I'm just going to make a little error box that goes, and now when we play this, we should see, because I've put something in here, the box is super, super small, but if I click the button, it pops up an error saying, right? It's that easy to get something up and running on the screen, and there's not very much code in this at all. Okay. So I said we were going to write a Tetris game, so let's move it on a little bit. Hold on, I've got a command that I can use for this. P2, git checkout. Sorry, my hands are shaking. I am so super nervous right now. If anyone tells you, you know, how do I get over nerves when I'm presenting? You don't, you just do it anyway. Okay, P2. Right, so now we've got a little bit more going on. Let me show you what that looks like. One of the problems with having all these lovely integrated games and everything else is you can't manipulate them, right? If I've not declared the HBox, I can't get hold of it very easily. So I wanted to show you how I manipulate stuff. So now we've got a button, we click it, it goes to a next tab. I actually moved to a card layout later, which is much more sensible. But you can see it's got some stuff on the screen. I'm literally just saying, I can display stuff on the screen. This is pretty typical for how I get things working. I just want to know how do I show that I've got something working, and I'll do random things in it just to show that. But here's how you do it. You declare this thing, and this single assign means it's kind of like lazy. You assign it once and then it's done. There's a lot of dependency injection stuff available to you in Tornado, and I'll show you a little bit more of that later. You can see the action here just selects the game tab, and we've just assigned the game tab pane and then the game tab using this, and that allows us to manipulate things. That's actually a really big smell in Tornado. Every time you need to grab hold of a component like that, it's because you're not binding it to a view model. And I want to talk about view models and show you view models a little bit. I never quite cleared up all the code, but we did get some view models. At the moment, the only place where the view model exists is down here in this grid view model. So if I go to my game view, if I go to my, I think it's still in the main view, in fact, you can see down here, I've bound, it says bind children here. So I've got a group. A group is literally just a collection of things. And then I've bound the children, which are these squares, and it's giving me a rectangle and picking up the color from the binding. Okay, so when this binding changes, the screen will change as well. I'm not doing that at the moment, I'm just literally showing it. But this observable list, that binding means the front view is observing the list. So you're probably used to MVC. Always have slides as backup when you're doing live coding. this is MVC. You're all used to this, right? You've got a controller. It's got some models. It passes the models to the view. The view reacts to it, and they're probably talking to each other a bit. With a view model, what we're doing is we're wrapping the model inside something that is the presentation that the view requires. And we can bind things to that, like buttons being enabled, disabled, things being visible on the screen. And it means that we're not trying to put stuff like that in the model, and we're not trying to put that logic in the view. It's got its own place that it belongs in. So that binding thing is really key in Tornado. So every time you're manipulating things directly, you could use a view model instead. Like I said, I never quite got round to clearing up everything, but you can see there's some binding going on there. Okay, what else did I want to show you? Right, let's move it on a little bit. Right, so we're now on P3. Okay, let's play the game. What's happening now? So we've got a new game. Okay, so there's nothing visibly different about it, but something is happening behind the scenes that's really interesting, and it's up here. So we've got this events class coming in through dependency injection. I did that mostly just to show you the dependency injection. I was talking to Nat Price yesterday. He said, you don't need to use dependency injection with Kotlin. It's simple enough. You could actually put everything through the constructor. And that's true. I wanted to show you just how this works. So if I go to the Hellbound class now, you can see we've overridden the start, and we've added this DI container and overridden some stuff in that. And if I actually look, we've injected this injector module. So this is one of my classes. And we've just got an events class in there. So when I first did this in Swing, I did it the same way. You have a queue, you have some events that go into the queue, some events that go out of the queue, and some stuff that subscribes to the events. And it's a really, really nice way of keeping that thing between them completely separate. So now instead of having a controller that talks to a view model that talks to a view back and forth, all we're doing is we're sending everything through this events bus. Okay? This means that the view is never, ever going to make any decisions about what happens at all. So what I do is I have requests that come in from the view. The view says, hey, a player did something. Here's a request. And the back end says, okay, I see your request. Here's what's changed, and notifies the view when things work and things need to change. That's really, really simply done here because we've only got one thing that's happening, which is when we click the button, it goes through to this game starter that's subscribed to the events. When the game starter sees, hey, can you start the game? It goes, yes, start the game. Really, really simple, but it's just to illustrate how this works. Okay, little gotcha. If you go here, you will see, in fact, it's in the ejector module, you will see this here, this value here. It's not used. Do not delete your unused values. If you do, the garbage collector comes around. It goes, oh, well, you're not using this anywhere. And because the events bus is not persistent, you will find that the entire engine for your game gets garbage collected. And it will happen slowly enough that your automated tests will not pick it up, but you will be playing and suddenly everything will stop. Okay, so there's a gotcha. That took me a couple of hours to work out. All right. So let's move it on a little bit more. I said I was going to go quickly. Okay. All right. So now let's have a look at what's going on when we play the game. So here's a game. We're going to do this. And, oh, there's some shapes on the screen. Look, it's starting to look like a Tetris game now. And we can actually move this shape. We can move it off the boundaries. Never mind. We've started. We've got something on the screen. It can go all the way down. When it gets to the bottom, nothing happens. It just goes off the bottom. There's no up in Tetris. But so we can at least move some stuff. We're doing some things, which means we have some behavior. We've got some behavior that's actually interesting. So for the first time now, we've got some scenarios. So let's have a look at these. Okay, so you can see my scenarios here. They say things like the grid should start empty. I absolutely love that you can make functions, strings in Kotlin. I only ever use it for tests, for the scenarios, and I'll show you the unit tests in a moment. You can also see that I've got given, when, then in comments. Has anybody not come across BDD here before? You all know BDD, you all know given, when, then, right? So this is how I start. I'm not using any frameworks. I'm not using any tools. It's very procedural right now. I've just got started. So I've got, it's a bit messy. That's fine. It's got all the glue that makes it look pretty here. But you can see it's enough, right? And this is documentation. The way I think of BDD is it's documentation for how the system works, how the system behaves, not just tests. When I want to know how something behaves, when I've come back to my code after a long time because I'm programming in my spare time, this is how I find out what was I doing, how do I understand the code. Okay, so you can see we've got some scenarios running. It's running just fine. I can run these. Let's run them all. Run all the scenarios. This is automated. I'm using an automation framework that I wrote myself called Stirry. I have a very bad habit of reinventing the wheel when I don't understand something. So I tend to write automation frameworks when they don't exist. So you could just see it just flashed up on the screen there, and it is actually running. The grid starts empty, pressing a key, starts the game, and then you can rotate and move the shapes around. Okay, there's a problem with this. I want to show you what happened the first time I did this, and it has to do with this little thing here. So I'm just going to remove that, and we're going to do it again, and you'll see what happens. It failed, okay? It failed, and the reason it failed, if you come down here and you look down here, it's expecting empty grid. I've got a string representation of the grid, but it's had a T-shape at the top, so that's the grid starts empty. And it doesn't start empty. It's picked up a T-shape. It's done it super fast, so I'm not going to show you. The reason it's done that is because that scenario started in the same JVM as the previous scenario. So it's picked up all the stuff that was a singleton, all the stuff that I dependency injected from the previous instance. If I want to stop that happening, I have to scope my dependency injection. That's why that's there. There's a whole ton of stuff around scope. So Edwin Sayce, who wrote Tornado, he's got some beautiful, beautiful manuals that explain everything that I'm telling you today in much more detail and much more beautifully than I can. Scopes are really, really useful for testing. So just remember when you're testing, if you get this interaction, it's probably because you haven't introduced the right scope. Okay, let's move it on. What's next? Scopes, scenarios. We've looked at scenarios. Oh, unit tests. I didn't show you the unit tests. So we do actually have, I think there's a controller test in here. So the difference between my scenarios end-to-end and my unit tests is my scenarios are looking at the whole system. The controller test is only looking at the one class. So I'm actually mocking out the game here using Mockito, one of my favorite mocking frameworks. I'm given to understand that there's some really nice Kotlin-based mocking frameworks, and you can do all kinds of fun stuff with functions. But I don't get to pair. If anyone wants to come and make this look better with me afterwards, you're welcome to do so. I'm just using Mockito to mock out the game. So this is just, it's got the same structure of given, when, then, though. So the idea is given is a context in which your system starts or what your class is set up to have, and then something happens. Either you use the class or something happens with the system, and then you get some result at the end. And I use the same pattern of BDD for unit tests as I do for those end-to-end scenarios. So I see this given, when, then everywhere. You'll see later that system level, I tend to refactor out that given, when, then into something a little bit more readable, a little bit more reusable. The comments, just leaving the comments in here has been enough. I've never found the need for any of the spec-based frameworks. I just really like leaving them in comments. It's very easy. And again, one less tool that newcomers need to pick up. So there you go. That's the unit test running. I'll just run them so you can see they do run. There you go. And they all start with word should. So this class should do this stuff. Okay, what's next? Oh, I got a presentation somewhere. There we are. Okay, so that's going to be fun. Where's my thing? P5. Please bear with me while I just get these bits. There we go. Okay, so we've moved it on a little bit more. So let's now look at the game again. Just going to run this. Something interesting is happening, and it's super, super exciting. When I start the game, and there's a shape. Oh, it broke! Everything went horribly wrong. Why is everything going horribly wrong? Let's go have a look. I know what, my automated scenarios, they should be able to tell me what's wrong. If I've got a bug, I should be able to go to my can, play the game, and I should be able to just run this, and it will tell me what's going wrong with the game, right? And this is why you should never, ever rely on your automated tests. Always, always check it manually, okay? The tests here are working absolutely just fine. So let's find out again what's going wrong with this. Okay, let's run this again. And this time I'm just going to quickly look at the stat trace and we'll be able to see what went wrong. Okay, so starting the game, and okay, there's the error. So let's quickly look at that. And it says, not on the FX application thread. So what's happening is, when I'm in my automated thing, Stirry, this little automation framework I wrote, it's actually running these events on the heartbeat notification on the FX thread. So there's two threads, there's the main thread and there's the JavaFX thread. JavaFX gets really, really upset if you try to make events happen, if you try to make things on the GUI happen, do not happen in the FX thread. And that's what's going on. So there's a couple of ways of dealing with this. One is, if I look in the injector module again, one is that you can declare the coroutine scope. So I'm using coroutines. I'll show you that in a sec as well. I'm using coroutines for the heartbeat. I can tell you that when I did this in Swing and Java the first time, there was waits, there was locks, there was, all the thread model stuff. The class was about this long that made the heartbeat work. I'm using coroutines, and it's so, so beautiful. This is it. That's everything that does the heartbeat, and it accelerates over time. Okay, this whole game took me about a fifth of the time to write in Kotlin with Tornado than it did when I did it in Swing. And I know I've got some learning already from that, but it's still so super fast in comparison. So here's the heartbeat notification. This is where it's pushing the events through. There's a couple of things that we can do to fix it. One is to introduce the coroutine scope, inject it, and do it here. And the other one is to use the bridge. And I can put dispatch main in there. Now, the dispatch main does not come, dispatchers, main. There we go. That doesn't come from TornadoFX or JavaFX or anything else. That's in the Kotlin's coroutine, but it doesn't work unless you've got the bridge in your class path. So it's kind of magic. In retrospect, I think I would prefer that first way because it needs that in its class path, that JavaFX there. If it doesn't have that, it fails. And then you're left with magic, which doesn't really fit with me and Kotlin's whole type system. So in retrospect, I would probably use the other way and do it explicitly. Okay, but we've got something working now, and now when I run Hellbound, so I can't remember where we were, so I'm just going to run like that. Now when I run it, it should work, and you can see the shape drops over time. Okay, so that's all that's happening now. Brilliant. Coroutines, we love them. Okay, and the JavaFX bridge. These slides will be available, by the way. All right, let's move it on. Where are we? P6. Force it. There we go. All right. So let's play it again. Something really pretty happens now. So now we've moved the game on a little bit. We have an actual game, and it's pretty. It's got some stuff so you can see where the columns are because I kept getting fed up of dropping the shapes in the wrong place while I was trying this out. And I'm not brilliant at Tetris, but I said I wasn't brilliant at Tetris. Look at that gap there already. Hopefully I get something. There we go. So we can make a line, and the game is actually working. There's a nice little score mounting up on there. And when I click it, it's going to go to a nice little overlay screen that will tell me the game is over. And it will say, game over, man, game over, in tiny, tiny writing. Okay? So we've now got this pretty game going. Let me show you how that's working. It's in the game view. So the game view is still bound to this grid model. It's still picking up the color from the grid model. But now it's got these radial fills that are giving those squares their lovely shading. Okay, and you can see the isEmpty one, and those little dots are caused by making a circle that's a bit too big, and then it just leaves those little dots behind. And the all the other shapes which aren't empty, they've got these lovely radial patterns to them. That means that our grid view is now a complete mess. And if we were to try and do that for everything, we would have presentation logic absolutely everywhere. Traditionally, with JavaFX, we would get rid of that by using a style sheet. Style sheets are CSS type. They look a lot like CSS. CSS is just strings. If you get the strings wrong, then it either doesn't display or it gives you some kind of error. And you don't find that out until you run them, which is not like Kotlin at all. We have something else we can do. And this is one of my favorite things about Tornado. Okay, so now we're using these styles. TornadoFX has type-safe style sheets. So I've wired this into the main app. You can see here. That's how you wire it in. Is that styles class? It was there, but it was just empty before. And now I've got this CSS class. You can also do things by CSS elements. So if I wanted to, there's an IDs. There's all kinds of ways. I just declare some style that I want by CSS. Element, ID, properties. There's all kinds of things that you can use to do the selection of your elements. And you'll see if you want to check out the code, you'll see I've got some stuff around that as well later. I'm not going to do it because I'll run out of time. But here's the real magic. Because it's type safe, because it's declarative, I can actually put logic in there. I can actually say things like, if it's like this, do it like this. I've got a to rounded rectangle, I can call functions in there. You can't do that. You just can't do that with your ordinary style sheets. So this has been totally magic for me. Okay, let's move it on again. Oh, sorry. There it is. So this is where it starts getting really fun. Oh, sorry. Touching the type pad. Okay. All right, so now we've got a much richer style sheet. And when I actually go to Hellbound and I play, you can see it's going to be so beautiful. Right? There we go. So we've now got some much nicer style sheets. I am not a graphic designer. I am a cybergoth. It's black with shiny things on. Don't get me to design things because I'm not a good designer. But I can show you. We've made it even a bit prettier, etc., etc. When we actually lose the game now, something really exciting happens, and I can show you that too. This isn't the biggest change. Okay, so now when we've got a high score, I need to make that box bigger as well. Now we've got the high score. It's bound again with the grid view model, with the view model. So if I go to, I think it's the welcome screen, welcome view, again, everything's still happening with those requests and notifications. So I got a notification that a high score was achieved. Somebody's achieved a high score. This prompts the front end to pop up the dialog box, and it records with the high score, it says, okay, I've recorded the high score. And then the front end says, okay, well, now your high scores have changed. And the high score is bound to this simple string property. It still needs, it may look a little bit complex, but it's been so easy to change this when I got it wrong. It's been so easy to work out, should I have a dialog box? Should I do it from the welcome screen? Just because everything is separated. So there's multiple different ways I can look at things. It's a really nice tool for prototyping stuff as well. So again, we're bound to this simple string property. And when I declare my label, it's literally just bind highscores.text. There's the binding right there. And that changes when the string changes. And it's completely independent. So I can move those to different views. I could have something completely separated working on the event bus to pop up that dialog, and it would just happen. Okay. The really exciting thing, though, is what's happened to the scenarios. So I'm just going to escape presentation mode a moment so I can just show you these. So I can grab all the scenarios. So now if I run all the tests, there are very much more of them to start with. I also don't know why this is so tiny when I run it through the scenarios. This is a very, very high DPI gaming laptop because I'm a gamer. Something around this is making those super small. I'm not that worried because I'm not trying to run it with this. As long as it's testing, it's fine. Okay. I know from having done this before that those are timing issues. If I do it again, it will work just fine. I need to resolve the timing issues. So those failures are timing issues, but whatever. Okay, presentation. Into presentation mode. Right, there we go. Okay. In fact, it might well be because I had the class up. It might just be because I had that up. So now we've got these really, really readable steps. It says, given a game that's new, when the player presses any key, then the grid should look like, and I've got a string representation of the grid. Okay? All I've done is take those comments that said things like, given a game that is new, and I've looked at what the root is. So in this case, it's the game. There's some stuff around starting the game, playing the game, and then there's some stuff around the grids. There's some stuff around what the player does. I've extracted those into roots, and I've written a whole blog post on how I do this. This is where my real strength is, so if you do want to ask me questions, please make them about BDD rather than Kotlin. You'll get much more interesting answers. So this is the scenario class, and I've tried to keep this really, really clean. Each of those roots goes to an object that has all the nitty-gritty to do with those, and they're page objects. The really cool thing is hardly anybody that I speak to who does BDD and who uses the BDD tools, Cucumber, JBehave, hardly any of them are actually showing those scenarios to business people. There aren't people reading those. And those introduce another level of indirection. They're hard to maintain. You can't refactor them easily. Even my non-technical PO is capable of reading things like that, right? And the abstracting those out means I've now got some nice reusable steps. It's really easy when I want to add a new scenario to just add them. So I've started taking that duplication out. My product owner can read this, right? And as you can see, when something goes wrong, I can just dive into the steps to see what goes wrong. People have said to me, they've said, but you want to be able to read very easily why things go wrong. They're not tests. If you're doing this in real life, they should hardly ever go wrong at all. Them going wrong is usually because you've got some timing things that you need to sort out, which might mean a genuine race condition. We've encountered that a couple of times. It's going wrong because your design is not great and you've introduced regression bugs, and that's a sign to clean up your design. I prefer to think of these as examples of what the code should do. So I'm just going to run this again. I do think these failed because I had the thing up. So let me just run these again. All hellbound scenarios. There we go. I had a game up already. So I'm just going to run them again, just so you see them go green. There we go. Now it's working. Okay. I'm a huge, huge fan of automated scenarios. I'm an even bigger fan of unit tests. Because I was getting this ready in time for this deadline, I don't have as many unit tests as I like. I need to go back and do some refactoring and put those unit tests in. Please do pay attention to your test pyramids. These are just examples of how the game behaves. They're not rigorous regression tests, and I don't think anyone should use them that way. And that's it. It's game over. So does anybody have any questions? Anybody want to, was there anything you were hoping to see from this that I haven't shown you? In which case, I'm just going to tell you, there's one other thing on my GitHub. It's called Keogh, K-G-O-L, Kotlin Game of Life. If anybody wants to play with, it's JavaFX rather than TornadoFX, I'm going to convert it. But if anybody does want to teach Kotlin to other people, it's got the front end but not the back end, so you can actually put the engine for the game of life in really, really easily. I've used this for teaching people how to code, and if you're going to do it, I think it's a really nice way to do it. So it shows things on the front end as you get the rules working. If you want to come and geek out with me and help me make this game better and show me all the things I'm getting wrong with Kotlin, please find me later. Thank you very much.